Hi everyone, welcome to lesson 5, which is properties of ionic substances. Hopefully everybody got started okay last week with the first set of tasks. If anybody has any suggestions about work that they would like to do or tasks that they would like to do, then just pass on your suggestions and we can have a look at doing something a wee bit different. But for now, starter task as usual. This one's a wee bit different, where you have 4 columns and a list of substances. We'd like you to sort each substance under the correct heading. So some of the substances have their formulas written. That is so that you can see which kind of elements they are consisting of, and that should help you with that. Please do the starters because it lets us know who has picked up the knowledge from the previous lesson. What we're going to look at today, we're going to have a look at the properties of ionic substances. So things like electrical conductivity. We can't do any experiments, unfortunately, for this, but we're going to do at least some theoretical experiments. And we want to be able to identify the type of bonding present looking at the properties of a substance. So if we recap from ionic bonding, we're going to work today with sodium chloride, which we all know is the ionic substance that we all use probably every day. Table salt. So the bonding diagrams for sodium and chlorine atoms. The electron arrangements are 281 and 287. The sodium atom gives an electron to the chlorine atom and they become ions. Notice their electron arrangement has changed. They both have 8 electrons in their outermost shell, so they're stable now. They are no longer atoms though, they are ions now, which are charged particles. So you've got Na plus and Cl minus. This kind of blue line in the middle, these kind of arrows that I've drawn, represent the ionic bond. Now, ions, remember, are held together by an electrostatic force of attraction between these oppositely charged ions. That's what the ionic bond is. My question to you today is, do you think there are only 2 ions in a structure? So in a little grain of salt, are there only going to be 2 ions? Well, the answer is obviously no. We know this by looking at lots of different structures before this. There are millions and millions of atoms and ions that make up the substances we know. There are never only 1 or 2 present. What does this actually look like? Well, ionic compounds don't form these little molecules like covalent compounds do. There are a number of different shapes. There is one shape that they take, which is called, as the title suggests, an ionic lattice. Why do they do this? Well, positive and negative ions are formed, and they obviously, as we know, opposites attract. They are attracted to each other. So in a setup, this looks like every positive ion is surrounded by some negative ions, and every negative ion is surrounded by some positive ions, like this. And that is what holds the lattice together, the fact that there is a mutual attraction between the oppositely charged ions, in other words, the positives and the negatives. In the real world, that looks like a little cube-like structure. Sodium chloride is a cuboid type structure, and we call this an ionic lattice because it is a regular repeating structure. Now, if you are asked anything about the shape of an ionic lattice, these are the words you must say to get the marks. It is a regular repeating structure. I've put in a wee kind of side note here that it's crystalline. That means it's not obviously just one little cube like we said before. It's lots and lots of these cubes joined together to make an overall kind of giant lattice cube. So if at a really, really small scale, if you picked out one, that's what it would look like, but in reality there are millions and millions. So if you can, you could look at some table salt, just pour a little bit onto your hand if you're allowed, and you'll actually see that it does look like little cubes. That is the crystalline structure. That is all of those little cubes joined together in a giant ionic lattice.